Okay, I can take my time now. I'll try not to dawdle though. Okay, there's an ailment. Test medication, 50 volunteers. They all have a moderate case. Volunteers randomly assigned two. Old medication, new medication. Got it. Unmarked form, blinding, so that the patients and medical professionals do not know which medication the patient is taking. There'll be somebody with a record, kind of like I did with the Pepsi experiment, where there'll be somebody with a record of what what the difference is and who has what, but the people doing the evaluating and the people interacting with them and the patients themselves won't know. Which of the following is or are true? If the results show the new medication is significantly more effective than the old medication, we can conclude that the new medication will be more effective for all people. There's that all people that have a moderate case of the disease. They did not randomly sample from all the people who have a moderate case of the disease. Again, this would apply to people who are like your volunteers. And if your volunteers are unusual in some way, then you wouldn't be able to apply it to the general population of people who have it. The group receiving the old medication serves as a control group. I like that. That sounds pretty good to me. You know, that's why they're getting the old medication, so we can compare it with something. This is an example of a double-blind experiment. That was what we noted earlier. And that's why earlier I thought that D was the correct answer. And, submit. Submit answer. Yay! Okay. Last multiple choice, and then we'll look at some free response. Study conducted. Blue light. Does it affect falling asleep? In various age groups. So volunteers for this study are grouped by age, and then half of each group blocking. So we've got and that's what the questions. I'm looking at the questions now, multiple choice, but sue me. The questions are first, what are the blocks? And so the blocks are the three age groups, because those are the groups that we're going to randomly assign within each one to decide who gets what. So the blocks are the age groups. Cool. The treatment is which thing they get. And so right now we're down to A and D. And so the response variable is how the eyes react to the blue light, or the response variable is the time it takes to fall asleep. How will we measure this thing? It should be in the problem. You're not a scientist. I mean, we're not a, scientist about this stuff. And their fall asleep time is recorded. So that's the response variable. That's how we're measuring it. Therefore, the correct answer is D. Okay, that's taking a look at the multiple choice ones. And, you could stop it here if you want to, if you just want to see the multiple choice. I'm going to just take a quick look at the free response. I figure, I got some time on this video. It's a Tuesday afternoon. So I don't know, let's take a look at it. And sampling experiments and 2016 free response question 3. Yes. Now this is one I think I had used earlier in the year. They went over it already. Yeah, they went over it. Yeah, I shouldn't do question 3 because they've got the video going over it. And so I think it would be going over this one that would be better. I hope you do it yourself first. I mean, I'll probably post this video and send it out sooner, but do it yourself. That's how you're going to get the practice. And I'm reading people's responses and sending them back feedback about what they would get for a grade, because sometimes people don't understand the way that they're vague in their responses. All right, so this is the tire problem. Right, this is the tire problem. Right, this is a tire problem, and so and this one is open-ended. And actually, this first question would have been very. This is a free response question, so it's appropriate for the test. So they're trying to decide is this old rubber tire or the new rubber tire, which one is better, and they've got 20 volunteers. They give them the same bikes, and they're going to bike as they do normally, and then return it, and then we'll measure it and see what the tires look like. It says the manufacturer wants to compare the new tire to the standard model tire, so they will use the standard model as a control group. Got it. So manufacturer determines match pairs design. Describe how to implement a match pair design for this experiment. So I actually got this one wrong. It's very easy to because you don't give the best answer. For some reason, when I was thinking about it, I was just not thinking about it clearly, and I was thinking, okay, so you've got the new tires and the old tires. So you'd have to decide. So you should. And then there's the front tire and the back tire. So you should. Okay, cut me some slack here because this is gonna be bad. So you have to take All right, so we'll divide it in two, and we'll have by front and back, and we'll have half of the front group get the new tire in front, and half of them get the old tire in front. And the other one, half of them will get the new tire in back, and the other half will get the old tire in back. And so there was 5 of each thing, and I thought, ooh, that sample size is low. I should simplify this, and so I didn't follow the idea of the front tire back tire idea. But then the question is, okay, well, what are you going to put for the other tire? These aren't unicycles, or you can't ride a wheelie the whole time or something. You need a tire on both of them, and so what's going to go on the other tire? Yeah, okay, I'll just say that. I hope that makes sense to you, like why my thoughts on this were stupid. And so anyway, so that's not the way to do it. The way they said to do it was, you're going to give everybody the front and everybody a new tire and an old tire, and you're going to randomize whether it goes front or back. And that way we'll be able to compare the difference between the new tire and the old tire in terms of how they wear differently. What's interesting about this one is that you don't literally have a control group. Instead, you have, it says as a control group, but you don't have a separate group of people who are just control. Everybody's participating, and everybody's getting a new tire and old tire, and we're going to compare the difference between the two of them and see, is the new tire statistically significantly better than the old tire. So you had to introduce a random element, and it says describe how to implement a match pair design. It's not liking the way I'm doing that, so there we go. For this experiment, they wanted you to say a little bit about how you randomize. Like, it wasn't enough just to say randomly decide which gets which, because they said describe how to implement it. So they're talking about, what do you have to do to make this thing happen? Often there'll be questions will say things like, you do not need to describe how you will randomize for this problem. When they're trying to limit the questions so you don't say too much. But in this one, they wanted something. So in mine, it was a coin flip. In my altered version, it's a coin flip. So, each one comes up, you just flip a coin, you decide whether they're going to get the new tire in front or the new tire in back. And at the end of this, we'll look at the difference between the new tire and old tire and see, is it statistically significantly, if you do old tire, let's see, the new tire should wear less. So old tire wear minus the new tire wear, and then you can see if that difference is greater than 0. Describe the primary advantage of using a match pair design. They had a couple of things on this. One thing was that it makes the groups more balanced. And so it's a method of control. You're ensuring that any differences due to amount that people ride or anything else, the new tire and old tire for each person is going to be ridden the exact same amount over the exact same road by the exact same person with the exact same weather. I don't know, going over like bumps, over curbs, jumping curbs and stuff. So, all those things will be equaled out for each person. So each new tire and old tire will be easy to compare the two. The other thing, though, is remember that because of this, you've got less variability. You don't have situations where like a bunch of the new tires are in front or a bunch of the new tires are in back or something, or some other variable, or if each person got all new tires or all old tires, you wouldn't have a situation where all the people who ride really far got new tires or got old tires, either one. So, but because of that, any difference that is there, any difference that we might be able to see is going to be more apparent. If the new tires are better, it will be easier to see it. It literally increases the power of the test. You didn't have to use that word, but it's going to make, if the new tires work, it's going to make that more apparent. We saw this with the dog experiment when we were applying the different treatments to work on our bone density. And when we separated out to each individual dog, it was much easier to see that the bone density, that one treatment was much better for bone density, because when we just looked at one dog at a time. Oh wait, that was blocking. Shoot, that's not match pairs. Never mind. Sorry, I was remembering that one. Okay, I'm trying to remember what match pairs experiment we did, but I can't remember it off the top of my head. So never mind. All right, last one. At the conclusion of this experiment, the manufacturer finds that the new tire design has experienced statistically significantly less wear. So they did this test, and it's statistically significant. Can the manufacturer infer that the new tire will cause significantly less wear for all bikers? So we saw that a few times. And no, because this is only for people who volunteered. So it's for people like the volunteers in this experiment. Sure, the volunteers for experiment involving tires, they're probably more hardcore bikers, just a guess. But otherwise, yeah. So for people like this, it'll work. Remember, random assignment. I mean, I said this earlier, but random assignment, cause and effect. Randomly sampling allows you to generalize. Okay, I think that's the big stuff on this free response. Hope the design stuff has worked out for you and that today you got to do some good work on it and some review. If you have any questions, make sure you email them to me. We'll have more practice stuff once we've gone through all the units. We've got about 5 more days of review. We're going to have 4 or 5. We're going to have probability on Thursday, and then that's unit 4. And then we've got 5, 6, and 7 to do, I think. I got to double check that. And the one thing is that I might spend an extra day on inference just because that's a really important part of it, and it'll be part of it'll be part of the test, like a significant part of the test. All right. Thank you very much. Have a great day. And Thursday is an asynchronous class, except for those people who want to redo their linear regression test. And we'll have a chance for you to redo your linear regression test. Okay, bye-bye.